Hi everyone. This is our research project, indoor applications of UAVs and drones, and these are our group members.
This is Karan Dhar.
This is Jordan Richardson.
I'm Kylie Moore.
I'm Luis Martinez.
So, for the introduction, we'll be talking about all these topics in this slide. So, first, we're going to talk about the definition. So, UAV drones or unmanned aerial vehicles are aircraft that operate without an onboard human pilot. They are remotely controlled and autonomously programmed to perform various tasks and missions. Versatility. UAV drones have a wide range of applications across different industries and sectors. They are used for tasks such as aerial photography and videography, agricultural monitoring, search and rescue operations, infrastructure inspection, environmental monitoring, and surveillance. Now, technology. UV drones are equipped with additional technology including GPS navigation, gyroscopes, accelerometers, electric motors, and high resolution cameras. These components allow drones to fly with precision, stability, and agility, capturing data, imagery, and from various perspectives. Benefits. The use of UAV drones offers several benefits, including cost effectiveness, efficiency, and safety. Drones can access remote or hazardous areas that are difficult for human to reach, reducing the need for manual labor and minimizing the risks to personnel. Regulations. As the popularity of the UAV drones grows, regulations governing their operations have become increasingly important. Government agencies around the world have implemented rules and guidelines to ensure the safe and responsible use of drones. Future trends. The future of UAV drones holds promise for future innovation and advancement. Key trends include the development of longer flight times, higher payload capacities, improved battery technology, enhanced data processing capabilities, and the integration of artificial intelligence for autonomous decision making.
Distinguishing between outdoor and indoor drones involves understanding their design, capabilities, and sustainability for different environments. Here are 5 key differences. So, first we have size and weight. Outdoor drones tend to be built to withstand different environments and have different key features relating to movement, flight time, among other options. Next, we have flight characteristics. Characteristics are also something that may vary by drone type, due to them requiring different features to fulfill their roles well, such as GPS, photography, speed, and altitudes. Durability and resistance will also vary between indoor and outdoor drones, due to the environment they are flying in. This may be shown in forms of weather resistance, propeller protection, waterproofing, and possibly even collision avoidance. Next, we have battery life and power. They will also likely vary greatly, as if the drone loses power indoors, you can likely find it and restore it, but outdoors, it may be lost forever. Outdoor drones will also need a lot more power to be able to fight against environmental conditions. Payload and applications will vary as well, due to their environment they are flying in, as well as possible applications being different too. Indoor drones tend to be better for autonomous task monitoring, while outdoor drones may be better for imaging, mapping, and delivery tasks. These are the 5 indoor applications that we have decided to focus on. First, we have home security and ambient assisted living, which is AAL. We also have logistics, industrial surveillance, maintenance surveillance, and malls. Indoor positioning systems in production lines, advertisements, events, and entertainments, and precision agriculture.
So, about AAL, what is AAL? It is ambient assisted living, and it refers to the concept of using technology to enhance the quality of life and support independent living for elderly and disabled individuals within their homes or residential environments. In the context of indoor environments, ambient assisted living focuses on integrating various technologies and systems to provide personalized assistance, improve safety, and promote well beings. And now, how do we make drones like these?
Creating an indoor drone for home security and ambient assisted living involves several key steps, including designing the drone, selecting appropriate components, integrating sensors and features, and implementing control and communication systems. Here's a detailed guide. First, we have to define the requirements and objectives. We need to determine the specific requirements and objectives of our indoor drone. There may be specific features or functionalities we want to incorporate, and we also need to consider the size, weight, and flight characteristics of the drone. That way it can navigate safely. Next, we need to select components and hardware. Some of the things we'll need to consider when building our drone would be the frame. We want it to be lightweight and durable. We also need to consider the motors and propellers. They will likely want to be brushless and high quality for efficient and stable flight. And we also need to consider these because of the power and thrust to weight ratio that they can output. We also need to purchase a good flight controller. This way we have stable flight performance and possibly autonomous flight modes and waypoint navigation. Next, we'll need to consider our battery. It'll want to be lightweight and high capacity. That way we have an extended flight time. We'll also want it to be easily secured and easily removable. That way we can recharge efficiently. Next, we'll need to consider sensors. We may need these for environmental monitoring, such as cameras for visual surveillance, ultrasonic sensors for obstacle detection, and temperature humidity sensors for ambient monitoring. Lastly, we'll need to consider our communication system. We'll want to use Wi-Fi or Bluetooth. That way we can have real-time data transmission between the drone and a ground control station. Next, we're going to want to look at sensors and features. Like mentioned before, a surveillance camera may be something we want to consider. We'll also want to look at obstacle detection and avoidance features, such as ultrasonic or infrared sensors, just for obstacle avoidance. Then we'll need to consider environmental monitoring. This may include temperature, humidity, and air quality sensors. And we'll also possibly want to have alarm system integration. This allows it to receive alerts and notifications of suspicious activities or emergencies. Next, we need to consider control and navigation systems. There are many flight control softwares. We'll either want to develop or use an existing one. This will manage the drone's flight operations, stabilization, navigation, and control algorithms. We also want to have a ground control station. This allows us to monitor sensor data from a mobile device or computer. And then we also need to have autonomous navigation. This could be utilizing GPS or IPS, which is Indoor Positioning System. This allows us to enable autonomous navigation and waypoint-based flights. Next, we have testing and optimization. We'll want to conduct extensive testing of the indoor drone in a controlled environment to validate performance, stability, and functionality. We also need to collect feedback from users and stakeholders to identify areas for improvement and optimization. And then lastly, but most important, we need to ensure that we're both safe and compliant with all rules and regulations. We need to implement fail-safe mechanisms and emergency procedures to mitigate risk of accidents or malfunctions, including features such as automatic return to home in case of signal loss or battery voltage being low.
To create an indoor drone for logistics, industrial surveillance, and maintenance surveillance, you'll need the following main tools: frame and motors. We'll start with a lightweight and durable frame for the drone, such as carbon fiber or ABS plastic. Then choose a high-quality brushless motor with sufficient power and thrust for stable flight in indoor environments. Flight controller. We need to use a reliable flight controller board with integrated sensors, gyroscope, accelerometer, etc. for stable flight performance. Battery. Select a lightweight and high-capacity lithium polymer battery with sufficient voltage and capacity for extended flight time. Opt for a battery with a quick charging capability to minimize downtime. Sensors. Integrate sensors for surveillance and maintenance tasks such as high resolution cameras with pan tilt zoom capabilities for visual inspections, thermal imaging cameras for detecting anomalies, and ultrasonic sensors for obstacle avoidance. Communication system. Implement a wireless communication system, ergo Wi Fi or Bluetooth, for real time data transmission between the drone and a ground control station. Ensure secure and reliable communication to maintain connectivity. Ground control station. Develop a user friendly interface for controlling the drone and monitoring sensor data from a mobile device or computer. Include features such as live video streaming, telemetry data display, and mission planning. By assembling these main tools and integrating the necessary sensors and communications, you can create an indoor drone tailored for logistics, industrial surveillance, and maintenance surveillance. Using indoor drones and indoor positioning systems for production lines offers several advantages, facilitating efficient operations and enhancing productivity. For example, precision positioning. Indoor drones equipped with specialized positioning sensors can provide precise location data within production facilities by flying close to production line equipment and infrastructure. Drones can accurately determine their position relative to key points of interest, enabling precise positioning and alignment of components, tools, and materials. Real time monitoring. Indoor drones enable real time monitoring of production line activities and resources by continuously surveying the production environment from aerial perspectives. Drones can capture live video feeds, collect sensor data, and monitor the movement of materials and productions along the production line. This real time monitoring facilitates timely decision making and proactive intervention to address issues or bottlenecks. Efficient inventory management. Indoor drones assist in inventory management by conducting aerial surveys and audits of materials, components, and finished products within production facilities by scanning barcode labels or RFID tags to inventory items. Optimized workflow planning. Indoor drones contribute to optimized workflow planning and resource allocation in production lines by collecting data on production line throughput, equipment utilization, and workflow efficiency. Drones provide valuable insights for process optimization and capacity planning. Flexibility and adaptability. Indoor drones offer flexibility and adaptability to evolving production requirements and environment. Unlike fixed infrastructure-based positioning systems, drones can be deployed quickly and reconfigured easily to accommodate changes in production layout, equipment setup, or operational needs. This agility enables manufacturers to scale production operations, reconfigure production lines, and adapt to dynamic market demands effectively. Using indoor drones and indoor positioning systems for production lines enhances precision, efficiency, safety, and adaptability in manufacturing environments. By leveraging aerial perspectives and real-time monitoring capabilities, drones enable manufacturers to optimize production processes, improvise resource utilization, and maintain a competitive edge in today's rapidly evolving industrial landscape.
Drones have applications in entertainment and advertisement spaces as well. Drones serve as dynamic visual displays that can showcase brand logos, messages, and multimedia content in creative ways. Equipped with LED lights or digital screens, drones can project images, animations, and videos onto ceilings or walls, or even floating displays. These choreographed drone shows feature synchronized movements, music, and lighting effects. Interactive elements such as audience participation or gesture-controlled drones can add an extra layer of engagement and interactivity, allowing attendees to become part of the performance. Drones offer flexibility and scalability for indoor events and entertainment productions. Unlike traditional tech displays or stage setups, drones can be deployed quickly and easily in various venues, including theaters, exhibition halls, and conference centers. Their agility and adaptability enables organizers to create customized experiences tailored to different event themes and venue layouts. Few specific examples are like drone light shows that are put out with fireworks nowadays, where they create big 3D moving objects in the sky. They're very neat. I've yet to see one in person. Another example comes to mind is first person drone racing, which is like little micro drones that attach a camera onto it, and that's fed to a VR display on the pilot so they can race through indoor environments. I could see that becoming a more popular entertainment attraction if it becomes more commercialized versus just home kit, uh, take your own drone kind of thing. Drones have applications in precision agriculture, offering several advantages, enabling farmers to monitor crops more efficiently, optimize resource usage, and improve overall crop yields. Here's a detailed explanation in 6 points. So, crop monitoring drones provide farmers with a bird's eye view of their crops, allowing them to monitor their plant health, growth patterns, and pest infestations with greater accuracy and detail. Drones equipped with high resolution cameras, multispectral or hyperspectral sensors can capture imagery and data that reveal insights into crop condition, enabling timely interventions to mitigate issues such as disease outbreaks or nutrient deficiencies. Drones can provide farmers with access to hard to reach or inaccessible areas of their crops, such as dense vegetation or steep terrain that are challenging to monitor manually. This accessibility and efficiency enables farmers to monitor remote areas of their fields more frequently, enhancing the effectiveness of their crop management practices. Early detection of problems. Indoor drones help farmers detect problems in their crops at an early stage, enabling proactive management strategies to address issues before they escalate. Drones equipped with thermal imaging cameras can detect temperature variations in crops, identifying areas of stress or water deficiency. This early detection capability allows farmers to take timely action, such as adjusting irrigation schedules or applying targeted treatments to prevent yield losses and maximize crop productivity. Drones enable site specific management practices in agriculture, allowing farmers to tailor treatments and inputs to specific areas of the fields based on localized conditions. By collecting data on crop variability and soil characteristics, drones can facilitate the implementation of precision agriculture techniques such as variable rate fertilization, irrigation, and pesticide application, optimizing resource usage and minimizing environmental impact. As the power to run a drone, some part of the farm is much less compared to the gas for tractors and other machine equipment. Indoor drones can contribute to environmental sustainability in agriculture by enabling more precise and targeted use of resources such as water, fertilizers, and pesticides. By applying inputs only where and when needed, farmers can reduce waste, minimize runoff, and leaching, lowering the environmental input footprint.
Now, for conclusion, indoor applications of UAV drones constitute a field with immense technology scope for research and development. These applications present distinct challenges and opportunities across industries such as agriculture, logistics, entertainment, and healthcare. Advancements in sensor technology, autonomy, and um, regul- regulatory frameworks drive innovations to meet market demands for automation, efficiency, and safety in indoor environments. Research and development efforts are crucial for enhancing drone capabilities, addressing safety concerns, and unlocking the full potential of indoor drone solutions. As the demand for indoor drone technology continues to grow, investment in research and development fuels economic growth, fosters technological innovation, and shapes the future of indoor automation and safety. Thank you so much. And these are our emails. If you have any questions, we would be happy to answer them.
Thank you.
Thank
Thank
you.
you.
Thank you.